All right, let's dive into something really cool today.
Sounds good.
The first ever 3D map of an exoplanet's atmosphere.
Wow.
We're talking about, weather patterns, elements, the whole nine yards.
Yeah.
Our main source for this deep dive is this awesome article from the European Southern Observatory, the EO,
Yeah.
about a planet called WASP 121b,
Okay.
or as the scientists nicknamed it, Tylos.
It does have a certain ring to it.
Yeah, it does.
Doesn't it? This ultra-hot Jupiter, located about 900 light years away,
Right.
is a prime example of just how diverse planets can be.
So what makes this Tylos so special, besides the fact that
Right.
we now have this amazing 3D map of its atmosphere, of course?
Well, for starters,
Yeah.
it's a gas giant that orbits unbelievably close to its star.
Okay.
We're talking a year on Tylos that's only 30 Earth hours long.
30 hours. Wow.
Yeah.
That's barely longer than a day here on Earth.
Crazy, right?
Imagine celebrating your birthday every other day.
Uh-
Must make for some interesting calendar planning.
And not only that, Tylos is tidally locked,
Okay.
meaning one side perpetually faces its star,
Wow.
while the other remains in constant darkness.
Oh, wow.
This creates some truly extreme temperature
Yeah.
differences across the planet.
So how exactly did scientists manage to create a 3D map of something so far away? Sounds like science fiction.
It is a remarkable feat
Yeah.
of engineering and observation.
Mm-hmm.
The ESA's Very Large Telescope,
Okay.
the VLT,
Right.
play a crucial role in this.
Very Large Telescope, VLT.
Yeah. This
Okay.
facility uses the combined power
Hmm.
of 4 individual telescopes, giving it incredible sensitivity.
4 telescopes in one.
It's pretty amazing.
That's impressive.
Yeah.
But how does that help them map an atmosphere?
So during a transit,
Okay.
when Tylos passes between us and its star,
Right.
they analyze the starlight
Okay.
that filters through the planet's atmosphere.
Gotcha.
Different elements absorb light at specific wavelengths, creating a unique fingerprint.
Interesting.
By analyzing these fingerprints
Right.
at various altitudes,
Yeah.
they built a layered,
Okay.
three-dimensional image of Tylos's atmosphere.
Okay, so we've got this incredibly advanced telescope and a transiting planet.
Right.
But what does the map actually tell us? What's the weather like on this distant world?
Well, hold on to your hats, because
Okay.
Tylos is a wild ride,
Oh, no.
weather-wise.
Oh, gosh.
They discovered a raging equatorial jet stream
Oh, wow.
whipping around the planet at mind-boggling speeds.
Really?
We're talking thousands of kilometers per hour.
That makes even the strongest hurricane on Earth look like a gentle breeze.
Exactly.
Wow.
They also found vertical winds acting like a colossal conveyor belt, transporting gas from the scorching hot day side to the cooler night side.
Oh, wow. So there's a lot of action going
A
on.
lot of action,
Yeah.
and the storms.
Oh, yeah, you mentioned storms.
Well, let's just say the Great Lost Spot on Jupiter
Right.
has got some serious competition.
This is making me really appreciate our relatively calm weather here.
Me too.
So besides these crazy winds and storms, what else is floating around in Tylos's atmosphere? What did they find in the chemical cocktail, so to speak?
Well, the study revealed a
Right.
fascinating mix.
All right.
We're talking iron, sodium, hydrogen, and even titanium.
Wow, titanium.
Yeah.
Okay.
Now, titanium is particularly intriguing.
How so?
Previous observations suggested it was absent
Oh, wow.
from Tylos's atmosphere,
Interesting.
but this study revealed it's actually present,
Oh, okay.
just hidden deep.
So it's there, but we just couldn't see it.
Yeah, just hidden deep within the atmospheric layers.
So it's not just about what elements are there, but also where they're located.
Exactly.
That's pretty amazing that they can determine that from so far away.
It is pretty amazing.
Yeah.
The distribution of these elements paints a picture
Mm-hmm.
of the planet's formation and the complex processes happening within its atmosphere.
Okay.
It's like a planetary fingerprint,
Right.
revealing its unique history.
Speaking of history, this 3D mapping technique feels like a huge leap forward
Absolutely.
in exoplanet research, wouldn't you say? It's almost like we've gone from blurry photos to high-definition video.
It's a game changer, no doubt.
Yeah,
We're
well-
no longer limited to basic observations.
Right.
We can now delve into the intricacies of planetary atmospheres,
Yeah.
revealing details we could only dream of before.
It's amazing.
But the question is,
Yeah.
what can we learn from this? What does this tell us about other hot Jupiters?
Uh-huh.
Are they all this wild?
Good question. It's incredible to think that we can now study the atmospheres of planets hundreds of light years away in such detail.
Yeah, it really is.
But this is just one planet, Tylos.
Right.
What does this discovery tell us about the bigger picture
Mm-hmm.
of exoplanets
Okay.
and the potential for finding other worlds like our own?
That's the really exciting part.
Okay.
This 3D mapping technique opens up a universe of possibilities.
Wow. So where could we go from here?
Imagine applying this to other hot Jupiters,
Okay.
comparing their atmospheric compositions,
Right.
and understanding the forces that shape these extreme environments.
So we could start to see patterns.
Exactly.
Maybe even figure out how these planets form
Right.
and evolve over time.
Yeah.
It's like having a whole new set of data points to work with.
It is.
It's like a whole new world.
A whole new world.
And it goes beyond just hot Jupiters, right?
Right.
This discovery paves the way for studying the atmospheres of smaller
Yeah.
rocky planets.
Mm-hmm.
Planets that might be more similar to Earth.
Exactly.
Now we're talking.
Yeah, we're talking.
That's getting to the heart of what everyone wants to know.
right.
Are we alone in the universe?
For the big question.
Yeah, the big question.
Yeah.
Could there be life on other planets?
And that's where things get really interesting.
Okay,
By studying the atmospheres
Right.
of these smaller planets,
okay.
we can search for what are called biosignatures.
Biosignatures, okay.
These are chemical clues that could indicate
Right.
the presence of life.
So we're looking for specific elements
Yeah.
or compounds that would be difficult to explain
Exactly.
without the presence of some kind of biological process.
Precisely.
Give me an example.
For example, finding oxygen
Okay,
in significant amounts, along with other gases like methane,
okay,
could be a strong hint that something is producing these gases.
right.
Potentially life as we know it.
Okay, so we're not just looking for oxygen.
Right.
We're looking for oxygen plus something else.
Yeah, it needs to be the right combination of elements.
That's mind-blowing.
It is.
We're talking about potentially detecting life
Right.
on other planets just by analyzing the light
Yeah.
that passes through their atmospheres.
Exactly.
It's like a cosmic fingerprint revealing the secrets of a distant world.
And the tools for doing this are only getting more powerful.
Really. So what's next?
The EOO is currently building
Okay.
the Extremely Large Telescope, the ELT.
ELT, Extremely Large Telescope.
When it's completed, it will be the largest optical near-infrared telescope in the world,
Wow, the largest in the world.
capable of observing even fainter signals from even more distant planets.
So we'll be able to see even more detail.
So much more.
Perhaps even study the atmospheres of Earth-sized planets orbiting in the habitable zones of their stars.
That's the goal.
That's so cool.
The ELT will revolutionize our understanding of exoplanet atmospheres,
Yeah,
bringing us closer than ever to answering the question
Right.
of whether we're alone in the universe.
it's almost too much to take in.
It is pretty mind-blowing.
But it's also incredibly inspiring.
Absolutely.
This discovery on Tylos is just the beginning.
Yeah.
It feels like we're on the verge of a whole new era of exploration and discovery.
It does feel like a turning point.
Yeah,
And while the technology is crucial,
right.
it's important to remember that it's the human ingenuity,
Yeah.
curiosity, and collaboration
Mm-hmm.
that drives these breakthroughs.
Right.
There are teams of brilliant scientists and engineers working tirelessly to push the boundaries of what's possible.
That's a great point.
Yeah.
It's easy to get caught up in the data
Mm-hmm.
and the technical details.
Yeah.
But behind every discovery is a story of human passion
Right.
and dedication.
Absolutely.
We should explore that a bit more.
I agree.
What drives these scientists?
Yeah.
What's it like to be at the forefront of such groundbreaking research?
Their stories are fascinating.
Yeah, I bet.
Imagine the thrill of analyzing data
Right.
and realizing you're the first person to ever see the signature of an element in an alien atmosphere,
That would be incredible.
or the excitement of developing a new technique that allows us to peer deeper into the cosmos than ever before.
It must be incredibly rewarding,
It is.
but also challenging.
Oh, yeah, that's
There must be setbacks,
Mm-hmm.
moments of doubt,
Mm-hmm.
and the constant pressure to push the limits of knowledge.
It comes with the territory.
It would be amazing to hear their perspective,
I agree.
their personal journeys in this incredible field.
It would offer a glimpse into the human side of science,
Mhm.
the dedication and passion that fuels these extraordinary discoveries.
Perhaps we can do a deep dive into that.
Maybe in the future.
Yeah, in a future
Yeah,
episode. But
that's
for now,
okay.
let's bring it back to the discovery on Tylos
Mhm.
and what it means for our understanding of the universe. So we've covered a lot of ground in this deep dive.
We have.
From the mind-boggling weather patterns on Tylos
Yeah.
to the potential for discovering life on other planets.
It's pretty amazing stuff.
It feels like every new discovery opens up a dozen more questions.
It's the nature of exploration, isn't it?
It is, yeah.
We push the boundaries of our knowledge,
Right?
and in doing so, we reveal just how much more there is to learn.
Yeah, thinking back to that titanium
Yeah.
deep in Tylos's atmosphere,
Uh-huh.
it makes you wonder about the assumptions we make when studying these distant worlds.
It's a good point.
You know,
It's a reminder that we're working with limited data,
right?
and our understanding is constantly evolving.
Yeah.
What we think is impossible today might turn out to be commonplace tomorrow.
The universe has a way of surprising us.
It sure does.
So where do we go from here?
Well,
What are the next steps in this grand adventure of exoplanet exploration?
the quest for knowledge never ends.
Right.
We need to keep refining our techniques,
Yep.
building more powerful telescopes like the ELT,
Yeah.
and developing new methods for analyzing data.
And we need to keep asking those bold questions.
Absolutely.
What other strange and wondrous atmospheres are out there?
Right. Who knows what's out there?
What kinds of planets haven't we even imagined yet?
Imagine a planet
Yeah.
with skies that shift colors
Wow.
as different elements circulate in its atmosphere,
Okay.
or a world with clouds made of organic molecules,
Interesting.
hinting at the possibility of life.
It's enough to make your head spin.
It is pretty mind-blowing.
We've come a long way from simply discovering exoplanets.
That's for sure.
We're now peeling back the layers, uncovering their secrets, and inching closer to understanding the vast diversity of worlds that exist beyond our solar system.
And as we continue this exploration, I think it's important to remember the human element.
Absolutely.
The scientists, the engineers, the dreamers who dedicate their lives to unraveling the mysteries of the universe.
It's their passion, dedication that drives us forward.
Yeah.
And who knows, maybe one day, someone listening to this
Right.
will be the one to make the next groundbreaking discovery.
I hope so.
Maybe they'll be the one to find that elusive biosignature,
Yeah.
the definitive proof that we're not alone.
That would be incredible.
Until then, we keep exploring.
Absolutely.
We keep questioning, and we never stop looking up at the stars
Yeah.
with a sense of wonder and possibility.
That's what it's all about.
Because that's what it's all about, isn't it? The pursuit of knowledge,
Mm-hmm.
the thrill of discovery, and the endless quest to understand our place in this vast and magnificent universe.
Couldn't have said it better myself.
Thanks for joining us on this deep dive.
It was my pleasure.
We hope it sparked your curiosity and left you wanting to explore even further.